Why exactly do greenhouse gases absorb heat?
The sun's radiation peaks in visible wavelengths between 0.4 and 0.7 microns. Our eyes have evolved to be sensitive to such light, while the radiation emitted by the Earth, because it is much cooler, peaks at infrared wavelengths between 8 and 20 microns. This is exactly the wavelength range which is absorbed by the various greenhouse gases, enabling them to form a blanket around the Earth, keeping it at a pleasant temperature. There is a window between 10 and 15 microns through which some infrared light is transmitted through the atmosphere and emitted into space, but the rest of it is more or less absorbed. One of the absorption bands of carbon dioxide occurs close to the peak of Earth's radiation spectrum, and it occurs where water vapor absorption is weak. Carbon dioxide is also a long-lived gas, so for these reasons it plays a very significant role in the atmosphere. Interestingly, the two molecules that are most abundant in the atmosphere, nitrogen at 78% and oxygen at nearly 21%, don't absorb in the infrared. Only the greenhouse gases do. Why is this? Molecules that are composed of two or more different kinds of atoms have vibrational modes of excitation that are triggered by infrared radiation. The nuclei of the different atoms in the molecule have a slightly different propensity to attract electrons. In an electric field, the slightly positive atom of a molecule moves one way, the slightly negative atom moves the other way, and since radiation is an oscillating electromagnetic field, the molecule starts to vibrate. This vibration represents an energy gain by the molecule and an energy loss from the radiation. Virtually all molecules composed of atoms that are different show this effect and absorb packets of infrared energy. Even molecules composed of atoms that are the same but see different local environments, such as ozone, where there is one oxygen atom stuck in the middle of two off to the side, will have some internal charge imbalance. But nitrogen and oxygen molecules don't have a permanent or an induced dipole. Hence, they are inactive in the infrared. Instead, they scatter visible light, their electrons absorbing packets of energy from incident light and releasing it in different directions, giving the sky its color. This explains why water vapor, carbon dioxide, methane, nitrous oxide, and ozone are greenhouse gases. While we don't affect the amount of water vapor in the air, it simply reacts to temperature, the concentrations of the other gases are increasing steeply beyond their normal equilibrium levels, causing global warming. Carbon dioxide causes about 70% of the enhanced greenhouse effect, 24% is due to methane, and 6% due to nitrous oxide. These gases are long-lived in the atmosphere, meaning that the excess greenhouse gases that we are putting out there will continue to make temperatures rise for a long time.